Hello everyone, welcome back to my channel. In this video, we are going to discuss about the topic of isoelectric point calculation of amino acids. Now, before going to the calculation part, let's have the discussion on the basic idea that what is isoelectric point. Now, isoelectric point is the pH value in the case of amino acids where they bear the net zero charge, right? And the amino acids, when they bear the zero charge, they usually form the Zwitter ion. Now, what is the meaning of Zwitter ion? We'll get to know sooner, right? While understanding the topic, we'll get to know it. So, Zwitter ion is that part or that state of amino acid at which it bears the net zero charge. And at that point, the pH value is called isoelectric point. The isoelectric point is basically defined with the symbol of Pi, like this. So how do we calculate it? It is calculated by averaging the two pK values within which the net charge on amino acid is 0. Now why we are focusing on the two pK values? Because there are amino acids in which we have more than 2 pK ranges. There are 2 pK values. We'll try to solve it. We'll try to go through those examples also, right? And we'll try to justify the formula, that is Pi is equal to pK1 plus pK2 upon 2 by using the example of lysine. Now in the case of lysine, if you see, there are 3 pK values given to us, right? For the COH group, it is 2.18. For NH2, there are 2 NH2 groups. So we'll do one thing, we'll designate these NH2 groups as NH21 and NH22. Now the first NH2 group has the pK value of 10.53 and the second NH2 group has the pK value of 8.95, right? Now which two pK values to be chosen to calculate the Pi value is an interesting topic, and that is what we are going to find. So to do this thing, let's do one thing. Let's draw the number line here. On this number line, we'll write the pK values in the increasing order. So the first pK value is 2.18, second pK value is 8.95, and the third pK value is 10.53. Just a second, let's rewrite it in a proper way. So the first one is 2.18, second one is 8.95, and third one is 10.53, right? So these are the 3 pK values we have, and we have to see that when the solution pK is in these values, when the solution pH value is between these values, then how the amino acid will behave. Let's say the solution pK is below 2.18. When the solution pK is below 2.18, in that case, the group NH2 group 1 and NH2 group 2 both will behave as what? Both will behave as basic groups. COH, it has pK value of 2.18, right? So even below 2.18 pK, it will remain the acidic group. But if you talk about the NH21 and NH22, they will behave as basic groups, right? Because their pK value is higher than 2.18. So what will happen? They will undergo protonation because the solution will give more H plus ions as compared to the base ions, or we can say OH minus ions, or we can say the solution is dominated in H plus ions. So these NH2 groups, they will undergo protonation. That means below pH value, below pK value of 2.18, what will be the structure of lysine? It will be COH, and here we have the NH2 group, and this NH2 group, that is second one, right? It will gain the positive charge by gaining the proton, so it will form NH3 plus, and here we have the hydrogen, and here we have again NH3 plus, right? So both the NH2 groups, both the amine groups will undergo protonation to give us +2 charge. That means below the pK value of 2.18 of the solution, what is the net charge on the amino acid? It is +2, right? Now within the range of pK value of 2.18 to 8.95, what will happen? Within this range, now the solution pK is more than 2.18, right? So in that case, the COH group has pK less than 2.18 or exact 2.18, right? So that means the COH group, that is carboxylic group, will now be more acidic as compared to the solution pK. So what will happen? If the solution, if the COH group is more acidic as compared to the solution's pK range, the pK range what we're talking about? We're talking about 2.18 to 8.95. This is the pK range we're talking about. In this range, the COH group will be more acidic than the solution's pK value. So it will give the what? It will give you H plus ion. But if you talk about the NH2 groups, if you look at the NH2 group first one, right, that is having the pK value of 10.53, its pK value is still greater than the terminal value of this range, that is 8.95. That means it is still more basic as compared to the solution, and if it is more basic, it will undergo protonation. So NH2 group first one will undergo protonation, and same story goes with the second group. That second group pK value is more as compared to the range of the pK value which we are talking about. So second NH2 group also undergoes protonation in the range of 2.18 to 8.95. Right? Basically, it's very simple point that if the solution pK is less as compared to the molecules pK values of the group, right, then they will undergo protonation. And if the solution pK is more as compared to any pK value of any group in the molecule, then the molecule will lose the H plus ion. So now in this case, in this range, what will happen? In the range of 2.18 to 8.95, the molecule will attain this structure. The COH group will lose the H plus ion, and both NH2 groups will undergo the protonation. It will again get the plus charge, and here we will have again protonated amine group. So within the range of 2.18 to 8.95, what is the net charge of this amino acid? It is plus 1, right? It is plus 1. Now in the range of 8.95 to 10.53, in this range, what will happen? The COH group has still more acidic strength, right? The COH has pK 2.18 and the solution pK is way more than 2.18. That means COH group will again lose the H plus ion here. So we'll draw it like this. It will be in the form of carboxylate ion. Now if we talk about the NH2 group second one, the second NH2 group has pK 8.95, right, which is less than the range of the pK values we are talking about. We are talking about 8.95 to 10.53, right? In this range, what will happen? The second NH2 group will not attain the positive charge. That means it will not undergo protonation. Why? Because now the solution's pK is more than the pKa of NH2 group, which is second one, right? That means now the solution is more basic as compared to the second NH2 group's pK. And because NH2 is basic in nature, its character is to attain the protonation, to undergo protonation. But now because the solution doesn't have much protons, because of the higher pK range, it will not undergo protonation, so it will remain NH2 group. It will remain NH2 group. But in the case of first NH2 group, its pK value is 10.53, which is again still on the higher side as compared to the solution pK value. So what will happen? It will undergo protonation. It will undergo protonation to form NH3+. I hope you understood why first NH2 group has undergone protonation, because its pK value is on the higher side as compared to the solution's pK range, the range we are talking about, this one, right? That means in this case, what is the net charge attained by the solution? The net charge attained by the amino group is here -1 from this carboxylate ion and +1 from the amine, right? Aminium ion, we can say. So it will be 0. Here it is the net charge. And if we go beyond the pK value of 10.53, in this range, what will happen? Now beyond 10.53, the carboxylate ion will definitely lose one H plus ion. So it will be in the form of CO minus. And NH2 group. NH2 group is acidic now as compared to the solution's pH, solution's pK. In the final range, that is above 10.53, the solution's pK is more as compared to the second NH2 group's pK. That means solution is more basic as compared to the second NH2 group pK. So it will not attain the H plus ion. It will not undergo protonation because there are less H plus ions, or we can say there is a lack of H plus ions available in the solution. So it will remain NH2. What about the first one? Now again, if you see, the first NH2 group has pK 10.53, which is on the lower limit of this range, that is above 10.53 solution we are talking about. That means solution is again more basic as compared to the first NH2 group pK. So it will again not undergo protonation, and it will remain like this. It will again remain the NH2 group. That means what charge it attains? It attains the -1 charge now. So if you look at this range, at the different pK values range, we have different sets of amino acids with the different charges, right? Now what is the definition of Zwitter ion, the ion which we talked about? So it is that state of amino acid where the amino acid has net zero charge, right? The amino acid possesses net zero charge. It is that state of amino acid. So if you look at here, this is the ion, this one is the Zwitter ion, because here the net charge on the amino acid is what? 0, right? And by the definition of isoelectric point, what we have done, that it is calculated by averaging the two pK values within which the net charge of amino acid is 0. And within what pK values the net charge is 0? Within the value of 8.95 and 10.53, right? That means the pi is calculated, isoelectric point is calculated by averaging the value of 8.95 and 10.53. So this is what the pK value, that is what is the pi value, isoelectric point value of lysine is, right? So I hope you understood how do we proceed in this problem, and how do we calculate the presence of different charges in the different pK ranges by just following a simple method of drawing the number line and going through the problem in different ranges of pK value. So I hope you understood this problem perfectly. In our next lecture, what we are going to do, we are going to find the pK, we are going to find the isoelectric points of different amino acids where the side group has, or we can say the side chains are basic in nature as well as acidic in nature. So bear that thing in the mind, that the example which we have taken about the lysine, it also has the side chain which contains the basic group, that is NH21, right? It again contains the basic group. So in a similar way, we're going to discuss about the side chain which contains the acidic group, and then we are going to give you the shortcut that how we can skip this whole long method, right, of finding the pi value and directly come to the shortcut method of how we can get the pi values of different type of amino acids, whether it contains the neutral side chain, it contains the basic side chain, or it contains the acidic side chain. But yes, this question can be of great importance, this concept can be of great importance when they will ask you that at what pK range the amino acid will get the different charge. So if the question asks within the pK range of 2.18 to 8.95, what will be the net charge on amino acid? So for that thing, you have to understand in a brief manner, the way we have done it today, right? So stay tuned to the next lecture. In the next video, we're going to discuss about it. Thank you. Have a nice day.